This is Algebra 2, Lesson 2.2, Arithmetic Series. So we're going to start with an investigation, and the first question is asking us to add the numbers 1 through 5. So 1 plus 2 plus 3 plus 4 plus 5. We can use a calculator to do that, or we can do that in our heads, and we can get 15. We're going to do the same thing with the numbers 1 through 10. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. We should get 55. So now I'm going to do the same thing 1 through 100. 1 plus 2 plus 3 plus 4 plus 5 all the way up to plus 100 is not actually something that I want to do in my head. I could grab a calculator and do that, but that would take quite a bit of time. So we're going to come back to that after we do a little definition and a formula. So an arithmetic series is adding the terms of an arithmetic sequence. We've been talking about sequences for quite a while, but anytime a list of numbers increases by the same value, that's a sequence, and then adding up all the numbers from that list of numbers would be a series. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's a sequence of numbers that increases by 1. The series, adding up those numbers 1 through 10, is 55. So I have a formula then, can add any list of numbers from an arithmetic sequence. We use the capital letter S to represent the sum of the series. To do that, we need to take the first term in the sequence, and then we add the last term in the sequence, and we multiply by the number of numbers in the sequence, and finally divide by 2. And so how that works is if I took 1 plus 10, that would be 11. And if I took 2 plus 9, that's another 11. And 3 plus 8, and 4 plus 7, and 5 plus 6. Basically, I have a whole bunch of groups of 11. Now, how many groups would be half the number of numbers? Because if I have 10 numbers, I'll have 5 pairs of numbers. So basically, if I do 11, which resulted from 10 plus 1, times 5, which was half of 10, I get the sum of 55. And I can do the same thing for my 100 numbers. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. I'm going to end up having 50 pairs of numbers because if I had 100 numbers and I paired them all up. So this allows me to easily calculate the answer to be 50-50. And so I'm going to use that formula so we can see everything in action. If we did the first number plus the last number times the number of numbers divided by 2, the sum of 100 numbers, 1 through 100, would be 50-50. So we're going to use that formula to help us answer 2 more examples. Example A says find the sum of the series 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So that same idea, 3 plus 30 would be 33. 6 plus 27 would be 33. 9 plus 24 would be 33. As long as that sequence increases by the same value every time, this formula will work. So I'm going to identify the 3 terms that we need to fill in the formula. The first number in this list is 3. The last number in this list is 30. And if I count up those numbers, I see 10 numbers. So the sum of those 10 numbers would be 3 plus 30. If I add the first and the last, times 10 because I have 10 numbers, but because I have 10 numbers, I have to divide that by 2 to get the number of pairs that I get. And 3 plus 30 times 10 over 2 gives me 165. One more example, starting with a sequence given in explicit form. Find S12 for the sequence at u sub n equals 12 plus 4n. So I need three things again: the first number, the last number, and the number of numbers. Because this says S12, I know that I'm going to be adding 12 numbers. And to get the first term and the last term, I'd have to substitute 1 and 12 into the explicit formula, just like we were doing on lesson 2.1. So 12 plus 4 times 1, 4 times 1 is 4, 4 plus 12 is 16. And un is actually u12, so I'm going to substitute 12 into that expression. 4 times 12 is 48, 48 plus 12 is 60. So now I have the three pieces that I need to substitute into my series formula. First number is 16, last number is 60. There are 12 numbers, which means I would have 6 pairs when I divide that by 2. And I should get 456. That is it for the notes. Please let me know if you have any questions, and good luck with the exercises.